Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam, October-November 2023, paper 42. Let's start it. Question 1. The table gives electronic configuration of some atoms and ions from A to J. Answer the following questions using the letter from A to J. Each letter may be used once, more than once, or not used at all. First, give the letter which is a noble gas atom. Noble gas has a full outer shell of 8 electrons, so we have B, which has 8 electrons in the outer shell. Then an element from group 6. Group 6 means it has 6 electrons in the outer shell. Here it's F with 6 electrons in the outer shell. Atom with atomic number 14. 14 is the number of proton because it's an atom, so it's a neutral. The number of proton equal to the number of electrons. So we have 14 electrons. The answer is D. D has 14 electrons. Atoms which are in the same group, so they have the same number of outer shell electrons. We have A and E with 5 electrons in the outer shell, the same number of electrons, so they are in the same group. Halogen atom, halogen are in group 7, so they have 7 electrons in the outer shell. Here we have G with 7 electrons in the outer shell, so it's halogen. An atom of an element which is a good conductor of electricity. Good conductor of electricity means it's a metal. So here we have C with only 2 electrons in the outer shell. That means it's in group 2, it's a metal, so it's a good conductor of electricity. Stable ion of group 5 elements. Group 5 has 5 electrons in the outer shell, so to form a stable ion, it gains 3 electrons to complete the outer shell to 8. So to stable ion from group 5, it has 8 electrons in the outer shell, so it will be B has 8 electrons in the outer shell. An atom which form an ion with a charge -2. Group 6 element has 6 electrons in the outer shell, so to form an ion, they will gain 2 electrons, so the ion will have a charge of -2. So we will search for an atom from group 6. Again, it's F because F have 6 electrons in the outer shell. Question 2. Cobalt and copper are transition elements. Copper has 2 naturally occurring isotopes, copper 63 and copper 65. And cobalt has only 1 isotope, which is cobalt 59. Complete the table to show the number of protons, neutrons, and electrons for cobalt 59 and copper 65, which is an ion has +2 charge. For cobalt, from the periodic table, the proton number is 27. Then to get the neutron, we will subtract 59 minus 27, it's 32, because it's an atom, so the number of proton equal to the number of electron, it will be also 27. For copper, from the periodic table, you will get the proton number, which is 29. Then for neutrons, we will subtract 65 minus 29, it will be 36. Because it's an ion with +2 charge, that means it lost 2 electrons, so the number of electrons will be less than the protons by 2, it will be 27. Table shows the relative abundance of 2 naturally occurring isotopes of copper. The first isotope 63 and the second is 65. Calculate the relative atomic mass of copper to 1 decimal place. To calculate the relative atomic mass, first we will multiply the mass of each isotope by its percentage, then we will add them together. The first one, 63 times 70, plus the second, which is 65 times 30. We will divide it by 100, so the relative atomic mass will be 63.6. One physical property of the transition elements such as copper and cobalt that they are hard. Other metals like lithium are softer. State 2 other physical properties of copper and cobalt which are significantly different from lithium. Other physical properties that the transition metals have high density and high melting point. C. Both copper and cobalt can form colored compounds. Some of these colored compounds contain water of crystallization. Define the term water of crystallization. Water of crystallization is a water molecule present in the hydrated crystals. Here, state the color and the formula of the hydrated cobalt 2 chloride crystal. Hydrated cobalt chloride crystals are pink, and the formula is cobalt chloride CoCl2 with 6 H2O, 6 water molecules. State the color change seen when few drops of water are added to the anhydrous copper sulfate. The anhydrous copper sulfate has white color. When we add water, it changes to hydrated copper sulfate, which is blue, so the color change from white to blue. State how this color can be reversed. Hydrated copper sulfate contain water, so we can reverse the color by removing water, and this will be done by heating the hydrated copper sulfate crystal, so the water will evaporate and the color again change into white. Question 3. Iron is manufactured in the blast furnace. First, state 3 of the starting material added to the blast furnace are coke, iron, and limestone. Name other starting material added from the blast furnace. Coke, iron, and limestone are added from the top of the blast furnace, and from lower part or near the bottom, we will add hot air to the blast furnace. So the fourth raw material added, which is hot air. The source of iron in the blast furnace is iron 3 oxide, which is found in the iron ore. Name the main ore of iron contain iron 3 oxide. The name of the ore is hematite. The iron oxide is reduced by the action of carbon monoxide. Here we have unbalanced symbol equation for the reaction. We have to balance it, so we will add 2 in front of iron to balance iron. Now we have 3 oxygens, so we will add here 3 in front of carbon dioxide. Now we have 6 oxygen. We will add another 3 here, 3 plus 3. Now we have 6 oxygen on the left side and 6 oxygen on the right side. State the oxidation number of iron in the reaction. Here in this equation, the oxidation number of iron in the iron 3 oxide is +3, and in the product, it's an iron metal. It's an element. An element has no charge, so the oxidation number is 0. The change in oxidation state of iron, it's changed from +3 to 0. Explain how the change in the oxidation number shows that iron has been reduced. Here we have to answer in terms of oxidation number. Decrease in the oxidation number is reduction. So here iron is reduced because the oxidation number decreased. The major impurity in the iron is silicon 4 oxide. Limestone is added to the blast furnace to remove this impurity. Write 2 equations to show how silicon 4 oxide is removed. For each equation, you have to state the type of the chemical reaction takes place. First, the calcium carbonate, which is limestone, thermally decomposed to form calcium oxide and carbon dioxide. This is the first equation, and the type of chemical reaction, of course, thermal decomposition. Thermal decomposition is the breakdown by heat. So calcium carbonate break down by heat to calcium oxide and carbon dioxide. Calcium oxide react with silicon 4 oxide to form calcium silicate, which is the slag. That's how the impurities removed. The type of chemical reaction here is neutralization or acid-base reaction, where silicon oxide is acidic oxide and calcium oxide is a basic oxide, so the reaction is neutralization or acid-base reaction. D. Iron is converted to steel by mixing it with carbon and other elements. State the term given to a substance which is a mixture of element and other elements. Of course, mixture of metal with other elements is alloy. Name one metal other than carbon mixed with iron in making stainless steel. Stainless steel is a mixture of iron with nickel and chromium. So here the question asked only for one element. We can write either nickel or chromium. Preventing the rusting of steel is very important. State the chemical name of rust. Here he wants the name, not the formula, so the name is hydrated iron 3 oxide. Steel can be coated with zinc to prevent rusting. These provide both a barrier method and sacrificial protection. State the term used for coating steel with zinc. Special name for coating with zinc is galvanizing. So this is a special name for coating iron or steel with zinc, galvanizing. To describe another barrier method for preventing rusting of steel, barrier method like painting or coating with plastic. Explain how zinc provides sacrificial protection. Sacrificial protection is a metal which is more reactive than iron, which can oxidize instead of iron or in preference of iron. So here we have zinc. Zinc is more reactive than iron, so zinc oxidizes in preference of iron, lose electrons instead of iron. Question 4. This question is about the salt, the insoluble salt lead chloride. A student prepare a sample of the insoluble lead chloride by mixing aqueous solution of 2 salts in a beaker. Identify the 2 soluble salts suitable for making lead chloride when mixed together. Lead chloride is insoluble salt, so to prepare lead chloride we have to mix 2 soluble salt. 1 soluble chloride salt and 1 soluble lead salt. So to search for any soluble salt, we can choose easily nitrate because all nitrates are soluble. So you will choose lead nitrate, which is a soluble salt for lead, and another soluble salt for chloride. We can choose a salt from group 1 because all group 1 salts are soluble. So here we choose sodium chloride. These are the 2 soluble salts that will be mixed to give the insoluble lead chloride. Write the ionic equation for the formation of lead chloride by mixing the aqueous solutions. Here is the equation for the reaction between lead nitrate, sodium chloride to form the insoluble salt lead chloride and sodium nitrate. To write the ionic equation, first we will remove the spectator ions, which have the same charge and the same state symbols in both the reactant and the product. So these ions didn't take part in the reaction, so it will be removed. Here we have nitrate of the same charge here in the product. The charge is the same and the state symbol is the same, aqueous, and of course also sodium, aqueous and aqueous with the same +1 charge. So the ionic equation will be lead ions, which are aqueous, plus 2 chloride ions, which is also aqueous, to form lead chloride, which is solid, the insoluble salt. Remember to include the state symbol because the equation is for 3 marks, so 1 mark will be for the state symbols and 1 mark will be for the correct charges, and the 3rd mark will be for the correct formula and the balance of the equation. List the steps that student should take in preparing pure sample of lead chloride from the mixture in the beaker. Now we have the solid lead chloride precipitated in the beaker. After that, we should filter the precipitated, then wash it with distilled water to remove any soluble impurities. After that, dry the residue between filter paper. Now we have a pure dry sample of lead chloride. The student carry out an electrolysis experiment on molten lead chloride using the apparatus shown. Chlorine gas formed at the anode escape from the apparatus. So chlorine formed at the positive electrode or at the anode. Here we have molten lead chloride, so the only ions present are lead ions and chloride ions. Explain why lead chloride need to be molten before it will conduct electricity, because molten lead chloride has free moving or free mobile ions. Write the ionic half equation for the reaction at the anode. It's already mentioned here that chlorine gas formed at the anode, so we have 2 chloride ions loses 2 electrons to form chlorine gas. Test for chlorine gas. Chlorine gas is a bleach, so it will bleach the damp lead litmus paper or the damp litmus paper, and the observation will be the paper bleached or it goes white. Describe what is observed at the cathode. Here we have only lead ions and chloride ions. So lead ions are positive. It will be attracted to the cathode to form lead metal. The observation will be the gray solid formed at the cathode. Of course, it's lead metal, so the observation will be just gray solid formed. Question 5. Chemical reactions can involve transfer of thermal energy. State the term used to the transfer of thermal energy during a reaction. Of course, the thermal energy change or transfer during the reaction is enthalpy change. Tetrachloromethane, CCl4, react with steam as shown here to form carbon dioxide and hydrogen chloride gas. The reaction is reversible, and it is mentioned that the forward reaction is exothermic. First, state what happened, if anything happened, to the rate of the forward reaction if the concentration of tetrachloromethane is increased. Explain your answer in terms of collision theory. Here he asked about the rate of reaction. By increasing the concentration of one of the reactant, the rate of reaction of course will increase, because increasing the concentration of tetrachloromethane, that means more reactant particles per unit volume, so more frequent collision, and of course this will increase the rate of reaction according to the collision theory. State what happened to the position of equilibrium, if anything, when the pressure is increased, because the question is asked about the pressure. So first we will calculate the number of moles on each side. Here on the left side we have 3 molecules or 3 moles, and on the right side we have 5 molecules or 5 moles. So by increasing the pressure, of course, the equilibrium will be shifted toward the side of less number of moles, which is the left side. Increasing the pressure, the position of equilibrium shifted toward left because it has a fewer number or less number of moles. Here we have the energy profile diagram. The figure shows the incomplete reaction pathway diagram for a forward reaction. So the reaction is already mentioned here that the forward reaction is exo. So in exothermic reaction, the reactant at higher level of energy than the product. So we will write the reactant here, higher energy level, tetrachloromethane, which is a gas, plus steam, which is also a gas, at higher energy level. Then we will write the product at lower energy level here, carbon dioxide, which is a gas, plus 4 hydrogen chloride molecules, which is also a gas. Insert the formula of the reactant to the product. We did it here. Then draw an arrow to label the activation energy and to show the activation energy. The activation energy with an arrow pointed upward from the reactant to the top of the hump, and we should label EA for activation energy. Draw an arrow to label delta H, show the transfer of energy in the reaction. Delta H is the difference between the energy of the reactant and the energy of the product, so it will be from the reactant to the product with an arrow pointed downward, and we will label it delta H. Define the term activation energy. Activation energy is the minimum energy needed for the particle to collide or to react. State one way in which the activation energy of the reaction can change. We can lower the activation energy by adding catalyst. So one way to change the activation energy is adding a catalyst. C. The question of the reaction between tetrachloromethane gas and steam can be represented by the following equation. Here we have the bond energy between carbon and chlorine, hydrogen and oxygen, then carbon double bond oxygen. Use the bond energy in the table and the delta H value here given, which is minus 130 kilojoule per mole, to calculate the bond energy between hydrogen and chlorine. Using the following steps. First, calculate the energy needed to break the bonds of the reactant, we have 1, 2, 3, 4 bonds between carbon and chlorine, so we will multiply 340 by 4. Then we have 1, 2, 3, 4 OH, so we will multiply 460 by 4. The total energy needed is the sum of these two energies, which is 3200. This is the energy needed to break the bonds of the reactant. We don't know the bond energy between hydrogen and chloride, so this is unknown. We only have the bond energy of the carbon double bond oxygen, which is 805. So the energy needed, energy released when the bonds in carbon dioxide is formed, we have two carbon oxygen double bonds, so we will multiply 805 by 2. It is 1610. We have the delta H, which is the difference between the energy absorbed minus the energy released, is minus 130. We have the energy absorbed, which is 3200. So we will use this equation to find the value of the energy released. Then we will get the value of the bond energy between hydrogen and chlorine. Here, 3200 minus the energy released equal to minus 130. So we will get the 4HCl as a subject of the equation. The energy of the 4HCl bonds is 1720 kilojoule per mole. So the bond for 1 HCl, the energy of 1 HCl bond, which is 1720 divided 4, it will be 430 kilojoule per mole. Then question 6. A homologous series is a family of organic compounds whose member have the similar chemical properties. Give two characteristics that are the same for all members of the homologous series. The members of the same series have the same general formula and the same function group. In terms of structure, state how one member of the homologous series differ from the next member of the homologous series. Each member is differ by CH2. Here I draw two members of the same series alkane. The first one has 4 carbons and the second one 5 carbons. So this is butane and this is pentane. As we can see, pentane has CH2 group more than butane. So the next member also always differ by CH2 group. Question C. A, B, and C are organic compound. A has the molecular formula C12H24. This the molecular formula of alkene, because the general formula, it follows the general formula CnH2n, where the number of hydrogen atoms double the number of carbon atom. So A is an alkene. B has the name of tetradecane with the suffix -ane, so it's an alkane. And C has 3 carbon atoms, and in the homologous series, the general formula is CnH2n plus 1 with COOH, which is the carboxylic group, so C is carboxylic acid. Name the homologous series each organic compound belongs to. The first one, A, is an alkene because it obeys the general formula CnH2n. The second one is alkane, as we mentioned, and the third one, of course, is carboxylic acid. Name C and draw its displayed formula. Because C has 3 carbon atoms, so it's propanoic acid. And for the displayed formula here, we have the displayed formula of propanoic acid, where here is the carboxylic group, carbon number 1, then carbon number 2, then carbon number 3. Here is the displayed formula of propanoic acid. Amino acids are homologous series where each member has the general structure shown in the figure. R is the side chain, contain carbon and hydrogen atoms only. Here we have the side chain, which is an alkyl group, contain carbon and hydrogen atoms only. An amino acid has a relative molecular mass of 103. Deduce the formula of the R side chain in the amino acid. So the total mass of the molecule is 103. We will add the mass of all the atoms together to get the value of R. First, R plus 1 nitrogen, so its nitrogen is 14, plus 2 carbons, 2 multiplied by 12 because carbon is 12, 2 oxygen, 2 multiplied by 16, then 4 hydrogens, 4 multiplied by 1. The total is 103. So we will make R the subject of the equation and subtract 103 minus the total or the sum of this number. R will be 29. Because R is an alkyl group formed from only hydrogen and carbon, so R is a methyl or ethyl group. Follow the general formula of CnH2n plus 1. The alkyl group has a mass of 29, so the alkyl group is C2H5. It's an ethyl group. State the name given to the natural polyamide formed from the amino acid monomers when amino acids join together to form a big polymer. It's protein. Here we come to the end of our exam. Like the video and subscribe to the channel to receive all the updates. Comment down below if you have any question. Thank you for watching. Wish you all best of luck.